Hi, it's Kifin Bates here, and because I've been looking at Solidity for the first time in a couple of months, I thought it would be interesting to record a Solidity video. Now, Solidity is the smart contract programming language for Ethereum and Ethereum compatible blockchains, and anybody who is familiar with programming in, for example, JavaScript will find that learning the syntax of Solidity is very, very easy. You can pick it up in a matter of days in that case. There are a few complexities. You don't have negative numbers, you don't have decimal numbers. You have this thing called a mapping, which is a way of linking a key to a value in a rather unusual way, I think. But apart from those kind of things, the syntax and structure of Solidity is remarkably uncomplicated. Nevertheless, writing smart contracts turns out to be very, very difficult, and that is because you have to make sure that they're secure. These smart contracts are handling real value. They're handling tokens that have a dollar price attached to them. Sometimes you end up with smart contracts that are holding hundreds of millions of dollars worth of digital assets, and as a result you have to approach coding in Solidity in a different way than you do if you're writing some JavaScript for a web page. It's further complicated by the fact that even though there are upgradable proxy systems that allow you to modify your smart contract after deploying, there is a kind of permanence to the code that you release in a way that, again, you don't find with, for example, web programming. And there are a bunch of known mistakes that you can make when writing a Solidity smart contract. A classic one is the reentrancy bug that you can have in a smart contract, whereby the order in which you put your statements becomes very important, because if you put them in the wrong order, then people can exploit your contract and siphon value out of it. So there's the issue with Solidity. It's not learning the programming language itself, it's understanding the ramifications of the bigger ecosystem when you're using Solidity to write your smart contract. And that's what sets a good smart contract writer apart from a bad one. It's very easy to do a one-week course, put on your CV or your resume that you are a Solidity programmer. It's another thing to build up the months and years worth of experience to know where things commonly go wrong and to code against that kind of thing happening. And so that's the difficulty, and that's unusual for a programming language, because I've not seen that kind of thing in anything else other than perhaps in the early days of embedded software programming, where you had to get the code right because it was going to go into 1 million devices and they would be shipped off to customers, and you don't want to have to recall 1 million devices to fix problems and bugs that you missed during the development phase. So for Solidity, really, the very important thing is to make sure that you handle the testing thoroughly. That's the main tool that a developer has to ensure that their smart contract is safe and robust. Testing, testing, and testing. You need to start with a minimum of 100% coverage for your contract, and if you haven't got 100% coverage, you need to have an explanation as to why there are some lines in the code that your tests didn't exercise. And that's just the bare beginning. Then you need to start looking at wider system level testing, where you try multiple things one after the other to see if there are any kind of interaction problems, and keep researching, because hackers keep finding ways to exploit contracts, sometimes years after those contracts are deployed. Anyway, that's the video on Solidity. I do think it's an enjoyable and fascinating programming language to work in, but more because of the environment in which it runs than the language itself, which is basically a cut down version of JavaScript. I hope you found that interesting, and I'll see you in the next video soon. Bye for now.